Thank you very much for the nice introduction. Respected dignitaries, esteemed guests, panelists, co-panelists, good afternoon. I'd like to really thank RUSA for this opportunity, for hosting such a very important event over here, especially at this point in time. What I would like to speak today is a little bit on designing training environments. One second, please. Yeah. Okay. Designing training environments for international employment. I mean, employability, let's put it that way. So, can we move to the next slide? Yeah. Why do we need learning environments or training systems as per se? Next slide, please. A big question mark, always. So, studies have shown that when you read something, like a lecture, like what we are talking about, there's around 20% retention, right? Next slide, please. But when we see, and here in a lecture room as well, there's 50% retention. But next, please. But when we practice, there is 100% retention, 90% retention per se. So, yes, okay. I think we're going a bit fast, but it's okay. I can just push on to it. Okay, so that was why do we need a learning environment. Okay, now, how does employability work? Every one in the industry would want to, when they hire someone, what are the questions, what are the factors they're looking for? They're looking for job-ready technical skills, right? They're looking for practical experience. They're looking for problem-solving, adaptability, yeah? Credibility, credible certification, basically. Digital literacy, yes? Online, working with online systems, working on MS Office and all that stuff, definitely. And obviously, cultural and organizational fit. So language also, the culture, work culture, how to work, what it demands, basically. And communication, teamwork, and work attitude, basically. So these are the points which an employer looks for. Okay. So how do we fulfill that? So we need to keep these points when we're designing a training environment. Yeah. So when we do that, the best practices what we have here are basically we need to combine theory and practice. What do I mean when I say combine theory and practice? We have in engineering colleges basically a very separate layout. You have a lab session and you have a theory session. Am I right? So you have 3 hours theory session and then 1 hour lab session towards the middle of the week. What happens there? Yeah, what have you seen? What have you read? After 3-4 days, you come and see something in the practical lab. A slight disconnect is there. What needs to be done is to integrate the lab and a teaching environment together, which means that when you try to teach, say, electrical machines, I'm going to show a rotor or something like that, but then when I'm teaching, then I can directly show the system. So retention is much more better in that regard. So the foundation is very good in that. So we have to combine theory and practice. Designing environments which combine and have an application approach. So learn by doing. That is very important. So you have to practice, you have to get your hands dirty, you have to work with them. Not just observe, but work, get into it. So, and enable individual learning. Why does this do that? Because you need to constantly upgrade your skills. So you should be able to work individually, not always supervised by someone. And you have to have a combination of theory and software and hardware. Software, obviously, e-learning, the big buzz, but you need hardware as well to practice what you've seen. Real-time hands-on experience, that's what is the key. And what you need is, you need softwares which will also help the student, help people to convert into the local language, because globally, anywhere, your regional language is your strongest language. You will learn in English, yes, but sometimes there's some things which maybe they would not understand. But if you have a regional copy of that software in your library, they can always go back and understand what they want to, what is the topic, where is an understanding. And yeah, so and learn by doing attitude. Do it yourself. You have to pick it out. You have to work with the system yourself, not supervise all the time, not give in everything. That's what we need to implement in a laboratory. Yeah. So the international labs setups. Why do we use international lab setups? Because we use these lab setups. It's very important to incorporate realistic systems or components, OEM components, which are there out in the world, which are being used so that the students get a first-hand experience of what is actually there. It is not a simulation. It is not you work with real components. If you're working in refrigeration, you work with Danfoss components. If you're working with automation, you're working with Siemens components. Exactly similar to that. And the international labs are designed as per the global benchmark standards. So Ohm's law is here the same, Ohm's law is there in Japan, Ohm's law is the same everywhere else. But there are certain topics which are standardized all across the globe, and these topics need to be in there so that it forms a very good tool for migration as well. So when you study these topics here and you're going somewhere else and these topics are already covered, it's a standardization approach. So and these systems are completely hands-on systems working on real-time components, real-life scenarios, project-based learning, real experiential learning. Okay. So let me just give you an idea of, if I talk about all these international labs and everything, how do we design it to put together all these topics? Yeah? So for example, my first, what is the first one? I mean, the first one is my goal, or the goal of every institution is to make people skills ready, right? So, yes, skills ready. Let's take the example of automotive. Everyone loves cars over here, I'm pretty sure, yeah? And we can relate to that very nicely. So, if my goal, or any institution's goal, would be to make people ready, hands-on, to be able to work on an actual car. But what we see over there, a car is a combination of different topics and technologies. Yeah? Very much so. And when you put a student on that car, it's confused. Where do I start from? What do I look at? What is the work of this? So what we need to do, we need to separate out each component, and make sure you have another level which focuses entirely on these things. So for example, I have an electrical vehicle over here. The electrical vehicle is the current buzz in the moment. That's the hot topic at the moment. So if I look at the cars over here, I would not be able to work on these cars directly because they're charged up, they're dangerous for the students, so safety is a main concern. So I need to make sure I work on these systems in a very safe environment. So what we've done is, have to make sure that you single out these systems. So for example, you have a battery management system, I need to remove it. In a very safe environment, you can power up, power down. Students are not hurt, neither is the system hurt. And no one else is getting affected with your experimentation. So when the student will be able to work on such systems, so singling out, so you have brake systems, you have battery management systems, you have the drive systems, every component will have their own system. But another question mark there is you have also a lot of different technologies at play in those systems. For example, a battery management system. You have the role of CAN bus, you have the role of power electronics, you have the role of regenerative braking, everything of that sort. So again, student, focus. Where should I focus? My aim is that the student should focus on battery management systems, only the function of batteries. So what what we have to do is we have to make sure you have different systems for the foundation level, for the fundamental level. Now, for example, if I now use the fundamental level and I train on CAN bus, I train on basics power electronics, I train on drive systems and everything, and then I move on to the second level, how confident is the student? He's much more confident. He knows on the background what's working, what is the role of every other component, and now I put together. Now, from step 2, I'm going to step 3. What happens then? He knows the role of battery management systems alone, and now he knows how it works in conjunction with the entire motor. So it's a step-by-step learning curve. So as you can see, the learning progression. Now this is important to have, the foundation has to be very strong. We are just having a discussion the other time about the number of research papers coming out. What is the fundamental, what is the pillar of research? Foundation. Yeah, when your foundation skill set is very strong, you can go into any stream whatsoever. So, next please. Now, if I put all of these together, this is an example lab. If I put all of these together, you have an electrical vehicle lab. Now you'd see over there, you have the U section, which looks into the basic fundamentals of any subject. So I'm going to cover all the basics over there. Then the level 2, I am going to have students move around in the level 2 systems, which are all different systems taken out from these, like battery management systems, drive systems, brake systems, everything individually. And the last level is basically you have the actual car, so they will be able to work confidently on the car. What we need is to build the confidence of the student. How does the confidence come? From practice. Yeah? And that's what we want. Hands-on working, hands-on experience, and the systems have to be safe to absorb student abuse. Let's put it that way. We were all students. We know what we can do. And we have to develop systems, or you have to incorporate systems which can withstand all that stuff. Yeah? So, remember I talked about blending theory and practice together? Similar setup. You have, this is a classroom where you have all the, where the trainer would touch on the theoretical subjects using PPTs or anything whatsoever, and then directly relate these topics to the actual equipment itself. So you have direct relatability. And the student is much more confident. He knows and understands, okay, this is what it looks like. This is how the rotation happens, and this is how he relates to it very well. The next, please. So, for example, this is not just a very nice picture. This is something which is doable and which has been done. So just to give you some glimpses, for example, Daimler Training Center in Japan. This is adopted in a similar manner, exactly the U shape, the different systems on the walls, exactly how we have explained it that way. The next page. So something else also implemented in Morocco. This is for electrical vehicles as well. Next page. China as well. I mean, they are also coming up with a lot of EV. So someone related in power would relate to this. This would be in ABB Technical School as well, a complete power plant in a laboratory. And coming from Dubai, we'd say DEWA, Dubai Electricity and Water Authority, also having their own setups in such a manner. Yeah. And the best reason why we should have this internationalization, the FTA. I would say congratulations to the government of India and the European Union to actually put together something like that. It's remarkable, it's very good. Special thanks to Mr. Modi as well. And yeah, how will it affect us? Yes, a lot of internationalization of products. A lot of products will come into the country. Like for example, you have already announcement of cars coming in at very low tariffs, and which means a lot of foreign cars, a lot of foreign industries coming in, a lot of workforce required on that standard. So a lot of companies come in to set up shop over here as well, and they would require the same going back as well. So they need manpower, as we've seen from the other panelists. You need people, which there's a huge shortage of skills in Germany as well, and then you have a lot of people going there. But skill set should be able to match and able to work in an international environment. Yeah. So thank you very much. for listening to me, for bearing with me, and thank you.